Yeah, so we are finishing trigonometry today with this last topic of looking at trigonometric functions and their graphs. And lastly, sine and cosine rules, which I think you have learned before. So before I begin this, I thought that you might want to look at maybe one question from what we did last out of the exercises that I left you to do. I don't know whether you tried these and checked whether you can do them. I thought of just picking one and maybe like showing you how to do one out of these questions. So let me start with that quickly. I thought of, I have chosen, so there are 1, 2, 3, 4, four questions, kind of like big questions. Let me do this number 3 with you. Did anyone try this? Anyone? Is anyone here who have tried these questions?
Yes, madam.
You did? Okay. So how were they? Did you find them okay? Were they okay? Were they? Okay. Who is this? To me, mata penne kawuda kiyala. Shine up. Okay. So if everyone is okay with these questions, we don't need to spend time on like working out one. So can you let me know maybe in the chat or by just directly talking to me whether we can just start trigonometric functions and their graphs today, or whether you would want me to maybe do one question out of these. Shainab says it, so they're okay. Can I take her word to represent the whole group? Or is there anyone who might want to see how to do one in this set of questions? Hurry up, huh? Hurry up, because I'm planning to take only the first half of the lecture today, the first hour, and after the break, hopefully, Kasuni madam can continue with your complex numbers lesson. So do one. Okay, Dainuka. Yeah. Rasindu, Nipun. Okay, Harshana. Yeah, sure. So thank you for that response. I thought of doing number 3. I hope, yes, Chamati, we'll do. Shall we do this number 3? So let's first read the question. Show that. So there are 2 parts. First part, show that. So you have to, it's like a, you know, show that questions in you have seen show that questions in papers. Bava pen one, da 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 da, me bava pen one. So they're nice questions because you know what you're supposed to do. So show that this equation given can be written in the form cos x equals k, where k is a constant. Now they've given this long equation. You have to show that it can be, this equation can be turned into the simple equation cos x equals a number, right? And then part 2, hence, what does hence mean? Hence can be called the nine, using that. So when you see the word hence, that means you have to use the result of the previous part. By using what you did in the previous part, solve the equation. That's the meaning of hence. Okay, right. So let me take you to the board. Okay. So we have, I have written it down here. I need to wipe my hands because it's a little, it's not warm, it's a nice day, but I'm sweating a little bit. Okay. We have sine x minus 60 minus cos 30 minus x, so that's in degrees, is equal to 1. we need to turn this into, we have to turn this equation into cos x equals some number, some k. K is some number. So in a way, this is not very difficult, because when you see sine x minus 60, when you see this term and the cos 30 minus x, this term, what should come to your mind are the compound angle formulas. We have formulas that we can apply to expand a sine a minus b term, or a cos a minus b term, or sine a plus b term, or a cos a plus b term. Okay, so it's just the direct application of, we have to apply the formulas for sine a minus b, because that's what we have a similar term here, and cos a minus b. Let me just quickly, okay, do you remember these identities? Sine a minus b, both sine compound angle formulas go sine cos, cos sine. The cos compound angle, formulas go cos, cos sine, sine. You remember that? Okay. So, and the sines, how do the sines go? So I hope you remember that. So if I apply this sine a minus b formula for sine x minus 60, it will be sine x cos 60. If it is minus, do I get minus or plus? Sine a minus b.
Minus.
Minus, yes. Minus cos x sine 60. Right? That is when I expand sine x minus 60. Similarly, I can expand that. Of course, Nandun. Yes, Nandun, thank you for letting me know. I'm sorry to hear that it's thundering in your area. You can watch the lecture later. Now, so Nandun just messaged me privately. I just want to appreciate that, comment on your good habits. Now, he didn't have to do that. You don't have to do that, right? I don't see if you just leave the meeting. Would I know? I would know. But you are still courteous and mannerful enough to let me know. So that's a very good quality that you have. Thank you for that. Okay. So, because you know, right, those things are important than mathematics. Maths okay, so okay, cos a minus b, cos sine sine. So cos 30 cos x. What about the sine? If it is minus there, Tivanka minus mother
Plus.
plus, yeah. Nandun, don't worry. I will be teaching you again next semester with mathematics too. Don't be sad. And I'm here always for you. Okay, for anyone, for anything. So don't feel like that. I know I have a slight sadness too, but I'm not showing you that. Cos sine cos 30 cos x sine 30 sine x equals 1, right? I expanded the two terms, the sine a minus b and the cos a minus b terms. You're welcome, Deshan. And so now I just have to, because what I have here are so it's only one angle, x, the unknown one. I have a 60 angle and a 30 angle, and those things I can actually write the value. I know what cos 60 is. I know what sine 60 is. I know what cos 30 and sine 30 are. So I can just put those values. So that's what I'm going to do next. Cos 60 here cos 60 is half. So sine x times half, I'm going to write it as half sine x. Half sine x. Okay, I wrote the half in front because that's what usually you do. If I write sine x half, that looks odd. Sankhya pitipassilli and I can bring it to the front end, make it look like the coefficient of the term. And then minus sine 60 is root 3 over 2. So again, that I'm going to write in front, root 3 over 2 cos x. And then minus cos 30 is root 3 over 2. So root 3 over 2 cos x. And then sine 30 is half. And then with that minus sign in front, that's minus half sine x equals 1. So I'm just working on the equation with the aim. What is my aim? I have to get finally, things have to get, whatever needs to happen. And finally, I need to get just one cos x term. So let's see whether that will happen. Okay. Right. That's where I'm going. You have to have that in your mind. Right. Anything simplifies here? Yes, of course. What's simplifying here? Half sine x minus half sine x. Great. And then I have minus on these two terms, the same term, right? Negative same term. So two of those gives me just two of those. Can you just root 3, isn't it? Minus root 3 cos x equals 1. I'm almost there. Almost I will at the end of destination. We are almost at our destination. Now I just need to make cos x the subject because that's what they want me to do. So it will be minus 1 over root 3. I got what I need. So this is my k. This is my k. This is my k. So they said k is they wanted me to get a constant there, so I got my constant there. You don't have to write it like that. Okay, so that's the first part. I have shown that this equation can be, I have shown bava pennua. They said to show this, I showed it. So this equation can be written in this form. So that's part 1. Now in part 2, hence solve that equation. In what range? They had given a range. Let us go back and check the range. I can't remember the range. My memory. The range 0 to 180. Very nice. Only half the circle we have to find the answers. Okay, not even in the full circle. Half of the circle. Hence, solve the equation. So we have to solve what equation? This big equation. But we have turned that big equation into a small equation. So instead of solving this, I can solve this because they are the same. So I am using the result, what I did in part 1. I'm doing the hence thing. Okay. So they have asked me to solve this. I would simply take cos x equals minus 1 over root 3. I want to solve that. So that's so easy. I just have to do a little diagram. Remember your diagram. All stations to Colombo diagram. My cos x is a negative number. Cos x is negative in which quadrants? And you have to think, where is cos negative? Cos is negative in the second and the third quadrant. That means I would expect an answer in the second quadrant, an angle in the second quadrant. Oh, do I have to go to the third quadrant? No, because they want me to give answers only in the range 0 to. How nice of them, isn't it? But if they had given me a full round, I would have to search for a second solution in the third quadrant, but we don't need that. Okay, we don't need the second one. Right, now you take the calculator and do what? You do x equals cos inverse of minus 1 over root 3. What does the calculator give you? 125.26 degrees to the nearest 2 decimal places. If we needed the second solution, Kianban, in case we needed the second solution or black angle, in case this was 360, what would be the second solution? How do we find that? We have got this this part, oops, brown. Now this part is 125. This is 125.26. Dinusha, if you do 360 minus 125, එතකොට ඔයාට එන්නේ මේකනේ. ඒ දෙකම එකද? Okay. එතකොට එන්නේ yeah. Do you see that? තේරෙනව නේද? Okay. So I hope so Dinusha said 360 minus 125. 360 minus 125 gives me this. මේ ඔහොම එකක් දෙන්නේ. But in value it's the same as that. So if they had if they wanted me to find solutions in one full circle, the second answer would be 234.74. Good, correct. Clear? Okay, I think those are okay. They're not very hard. Okay, shall we then look at trigonometric functions and their graphs? Okay. Right. Now, the sine, cos, tan, cosec, sec, and cot. You have seen 6 trigonometric, what do we call them? Trigonometric what? We call them trigonometric ratios, isn't it? Anupatane, trigonometric ratios. But in general, we can call them trigonometric functions because the word ratio we use when we are stuck in that right angle triangle. It's only when in the right angle triangle, it's a ratio between 2 sides. But with our new definition, it's just a function that depends on the angle. For any angle, there is a sine value of the angle. For any angle, there is a cos value of the angle. There is a tan of the angle. There is a cot of the angle. There is a cosec and a sec of the angle. So these are functions. These are 6 functions and they are trigonometric functions. And the bottom 3 are merely, they are just the reciprocals of sine, cos, tan. Sine anipet 1 over sine karama cosec, 1 over cos is sec, 1 over tan is cot. Okay. Right. So these are called trigonometric functions. It's a function. You remember functions? The input output, x is the input, y is the output. Your input is an angle. You put an angle, comes out a number. Okay. And you can think of the inverse functions of these. Inverse, which is the button that you press in the calculator when you want to find the angle, when you want to find the angle corresponding to a given value. So the inverse functions of those 6 trigonometric functions are sine inverse x, cos inverse x, tan inverse x, and so on. So for these functions, the input is a number, the output is the angle. Is that right? Is that clear to everyone? The original trigonometric function, in the trigonometric functions, you input an angle. X is an angle, y is a number. In the inverse functions, x is a number, y is an angle. Obviously, inverse cannot make a right. So you have to know the shape of the graphs of these functions. So if you look at if you think of how these graphs would look like, first of all, you have to know that they have to be periodical. Periodical means same thing happening again and again and again and again, because you are just going around a circle. These angles are, you're repeating 360, you are passing 360, but you're going on the same path again. So the graph has to look like that a certain shape has to keep repeating. Okay, so they are periodical. All trigonometric graphs are periodical. Navata ekama shape එක repeat වෙන graphs. And the domain of these functions are all real numbers. You can have, because you know that if when you start from 0, you can go in the positive direction, 360, you can go any amount you want in the positive direction. And you want to, if you want to go to the negative direction, you can go to the negative angles by turning the other way. So negative, positive, in all, it covers all possible number angles. Okay, so the domain is all real numbers for all the graphs. And we call the shape of these graphs the sine and cos graphs. I'm sure you have seen this. We came across this word when we learned about the types of functions. They are called sinusoidal. Sinusoidal is a nice word. Sinusoidal functions. You call any waving graph a sinusoidal graph, or a sinusoidal means sine-like. Sine wage, right? Sinusoidal. And sine and cos graphs, not the tan, sine and cos graphs, they are waving graphs. So they have a height, right? And we define what is called the amplitude of the graph. That is from the x-axis, the height. Now, when we see the graph, we will see it. I will take you to the graphs, and we are going to only look at the basic 3 sine, cos, tan graphs, not the reciprocal graphs. Okay, cos x and cot. If you want, you can just go and you can use Desmus. Remember Desmus, and type in the function and see what the graph looks like. You are free to do your own exploration and further learning as you like. There is no restriction like that. I'm just covering the basics. So here's your sine graph, a waving graph. What you have to notice is, sine 0 is 0, so it goes to the origin 0 0, right? It goes like that. And even though I have stopped, it goes on. This is a continuous, never-ending, periodical graph that goes forever. The pathatana, it's just waving. Okay, so period of this graph is 2 pi. Period is how long for one cycle. And that repeats. How long for one cycle? 2 pi, 360. Amplitude is 1, because in the unit circle, the maximum length you can go is 1 and -1. So you're restricted between 1 and -1. So amplitude is 1. Domain is all R. Range is -1 to 1. Range, right? And the cos graph is the same but shifted. Because cos 0 is 1, so the cos graph has to start from 1 and it drops down. But it's the same thing, same as the sine graph, but shifted by a 90, like a quarter of a cycle, shifted. Same period, same amplitude, same domain, same range, right? And it goes on forever, even though I have stopped. Right? It goes on. Then tan graph is a little weird. Like they're like snakes. And what you have to say, this might not be very clear. I might want to take you to the Desmus. Let me see whether I can take you to Desmus. Yeah, I have it here. Okay, let's because the tan graph, tan x. That's how it is, right? These are, separate infinitely many panu. They have no connection between them. Each line is separate. You have a discrete you have discrete lines, right? And there are what are called asymptotes. Asymptote means, now if you think of, let me change this to radians. This is giving me, it is in it is in radians, but it doesn't show me like in terms of pi. Okay, doesn't matter, right? So if I take you back, oh, can I draw here? Annotate. Right, like there is a line somewhere here, right? That's the line. What is this? What is this number here? Remember, tan what is undefined? Tan what is undefined? Tan of what angle is undefined, not infinity, undefined. As you start from 0 and go, tan which angle is undefined?
Tan 90.
Tan 90 is undefined. Tan 90 is undefined. So this is 90 or pi by 2. This is pi by 2. This point is pi by 2. At that point, there is no value for the tan. The red panua on this side or the red panua on the other side, none of the two give you a value. It never, this line never reaches this point. Pi by 2 and if you look at the other panua, it's going down, down, down. It never reaches pi by 2. At pi by 2, there is no value. Okay, from this side it looks like it's going to infinity, from this side it looks like it's going to negative infinity. So on the two sides they are giving you two extremes. So at pi by 2 it's not defined, right? And same thing happens at, again you calculate and see what this other one is, and again similar thing happens here, right? So there are values for which tan is not defined. So that's 90, again 270 or 3 pi by 2. This is 3 pi by 2. This is negative pi by 2. Again, somewhere here you have negative 3 pi by 2 and so on. Those are the points at which tan is not defined. Right. So, I mean, I invite you to use Desmus and explore further. Right? If you want, draw the cosec and secant graphs as well and see how they are. So again, this graph is periodic. Same panua repeats. Period is pi. Not 2 pi here, period is pi. Okay, you see that? From negative pi by 2 to pi by 2. That's a pi distance. And that repeats. Domain is all R. Range, domain is actually not all R. So that I will, it's actually, oops. Oops, wait. In the domain, making ayin karandone, pi by 2. These values must be removed from the domain. The domain doesn't have those points. Okay, because for that point there is no output, so there is no such input in the tan. For tan x graph, x valata pi by 2 danda ba, right? That value is not in the domain. So this is not accurate to say it's R. These values have to be removed. Okay, so don't think about that much. It's not that important to you. Okay, then I quickly want to show you. Simple transformations. You know, you can transform a graph now. For example, y equals sin x looks like that. If I multiply sin x by a number like 3x or 5x or negative 2x, what would happen? Now, like if I do y equals 3 sin x, the graph will transform. Have you watched Transformers? The movie Transformers? I always like, you know, a lot of mathematical terms have connections to movies, science fictions. Anyway, I'm sure a lot of you have watched Transformers. If I multiply my sin x by a number, like I have multiplied by 3 here, how would the graph look like? How would the graph look like? How would the graph change? How would the graph transform? මොකද මමක් වෙයි කියලා හිතන්නේ graph එකට. the period of the graph stays the same. One thing changes. Yes, Anushka. Amplitude goes up to 3. So it'll start oscillating between -3 and 3. Right? So by multiplying your sine, for cos is the same. Okay. For any waving graph, if you multiply your graph by a number, the amplitude will become that number. If you multiply by a -3, the graph will also flip. On the x-axis, it will flip. And it'll extend by that number. Okay. Another simple transformation. So this is sine x. If I change x, if I multiply x by a number, say if I do sine 2x, not multiply the whole sine, 2 x to them. Sine 2x, if I change the x input by multiplying the input by a number, like if I do 2x, what do you think will happen? Period changes. Very good. Okay. Period will be doubled. If I do 2x, the period will double. Means the frequency, it's waving more frequently with the double frequency. Okay. So if I halved it, it would stretch. And so on. Right. So just remember those two transformations. They might be useful for you. And yeah, I think that's all we have for that. And finally, we will quickly look at the sine and cosine rules. Just tell me, you have done this, right, in school? Sine rule and cosine rule. You have done this in school? At some point? O levels? Yes or no? I need a yes or a no. Okay. Don't remember is different from mataka naha කියන එකයි කරේ නැහැ කියන එක දෙකක්. So Anushka says can't remember, not sure වගේ එකක් කියන්නේ. Can anyone remember? Maybe කළා නැහැ. Okay. Okay, anyway. So you know that. So this is all about trigonometry. Now trigonometry means about triangles. Trigonometry. It's about triangles, right? Now you have the Pythagoras theorem for right angle triangles. Pythagoras theorem is a very useful theorem that you can apply on right angle triangles. Don't we have theorems that we can apply on any triangle? Now, Pythagoras theorem, you have that you can apply for a right angle triangle. If you know two sides, you can find the other side. If you know any two sides of a right angle triangle, you can find the third side by using Pythagoras theorem. And also by using the trigonometric ratio, sine, cos, tan, you can also find, if you know two sides, you can find the angles. Right? You can find all, you can find the angles. So just with Pythagoras theorem and the trigonometric ratios, if you know any two information of a right angle triangle, you can find all the rest. Information dekak dannawana. Anith okkama wage hoyaganna puluwan. Pada dekak dannawana anith okkama hoyaganna puluwan. If you know a side and one angle, still you can find the other sides and other angles, right? But the question is, don't we have similar things that we can apply on any random triangle? Right angle what if I have a normal just a triangle? We do. Okay, we have three very useful rules that are called sine rule and cosine rule that we can apply for any triangle. ඕනෑම ත්‍රිකෝණයකට යොදන්න පුළුවන් these two rules. So we'll see what they are. Sine rule. On top what you have is sine rule. I will just first tell you what it is. Sine rule, very easy. What it says is that if you take, no, let me take you to this first. If you take any triangle, okay, I'll call it A, B, C. Then you know that this side will be called simple A, simple B, simple C. So this is angle A, this is angle B, this is angle C. You take a side and an angle in pairs. Yugala vidiyata ganna. You take any side, for example, side C and the angle capital C in front of it. Sammukha kone, right? Side and an angle, side and an angle. So there are three pairs like that. Side C and angle C, side B and angle B, side A and angle A. What sine rule tells you is that, if you divide any side, let's start with side A. You take any side and divide it by the sine of the corresponding angle, capital A. That's a ratio. No? If you divide this side, by the sine of this angle, you get the same ratio. You get the same ratio if you divide side B by the sine of angle B. You get the same ratio if you divide side C by the sine of angle C. These are angles. That is sine rule. So it gives you a relationship between sides and the angles in pairs, right? There are three such pairs. The ratios between them are equal. So you can write it that way or the other way. Sine of any angle divided by the corresponding side is equal to sine of any other angle divided by corresponding side. Sine the next angle, third angle divided by the corresponding side. Usually they are both the same. Usually this is used, this way of writing is used when you want to find so you can use this rule to find an unknown side or an unknown angle. Like if you think of like set up one equation connecting two ratios. You look at this part. If you have three information, for example, if you have angle A, angle B and side B, you can find side A. If you know three, you can find one more. If you know two, so here, if you know two angles and one side, you can find here two angles, angle A and B, and one side. This side must correspond one of the angles given. Then you can find the other corresponding side. Here, look at this equation. If you know two sides, and one angle, you can find this other angle, remaining angle. The angle opposite to that one of the sides. So it goes in pairs. Is this clear? Let's look at a question, then you will understand. Have you not done this? Is this clear? Have you not done this? Two questions. Okay. Okay, so I was right? Okay. Oh, that's quite odd. How come you don't have this O levels. That's a bit, yeah. Okay, so that's what I have here. Sine rule here. It's the same thing. I've written the sine rule in 2 different forms. Yasira says you did. Are you studying for SFT? Did you have this in science for technology? Ah, only sine rule. Yasira says O level. Yeah, I think O level. Yeah. No, it's within my reach. I can take your SFT syllabus. I have it somewhere here. SFT not part? Okay, anyway, I should check that. Okay, so you have done the sine rule, right? Okay. Then cosine rule is what is new, I think. So, okay, if I summarize that again, when can you use sine rule? Area calculations. There you do sine rule. I will check that, okay? So when can you use sine rule? If you know 2 sides and 1 angle, or 2 angles and 1 side. If A over sine AB, then does A over B? Yeah, that's correct. Yes, same thing. Yes, Hasan. Wow, nice. That's correct, Hasan. Can everyone see what Hasan has written? I mean, okay, you can say the ratio between, that's another way of thinking about it. How wonderful, Hasan. The ratio between 2 sides, say A over B. Sanuj, mute kar dena, Sanuj. Okay. Sorry. Oops, where the game. Okay. You can also think of it as A over B. Like if you take any two, if I use these two, A over B, the ratio between any 2 sides is equal to the ratio between the sine of corresponding angles. Sine A over sine B. Yeah, correct, Hasan, same thing. But we like to put it in this form. Side and the sine. Side and the sine, or sine and the side. But it's the same thing. Yeah. Okay. Right. What is cosine rule? So again, let me write here. Sine rule you can apply if you know 2 sides and 1 angle, or 2 angles and 1 side. So you know 2 sides and 1 angle, then you can find the third angle. Okay. You can find an angle. If you know 2 angles and 1 side, you can find another side. So is that clear? Cosine rule, in cosine rule, this is actually, again, I will take you to this, because I want you to see a similarity between, okay, now when you have a right angle triangle, and if these 3 sides are A, B, and C, Pythagoras theorem says C squared is equal to A squared plus B squared, right? Now, if you have a random triangle, not a right angle triangle, okay, and say ABC, so none of the angles are right angles. Here, this is a right angle, right? So you have a random triangle. Then also, there is a rule similar to the Pythagoras theorem. See how similar you choose now. I will take the same side here. C squared is equal to a squared plus b squared. Well, it doesn't stop there. Now for a right angle triangle, that's it. Okay, your hypotenuse is equal to the square of the hypotenuse is equal to the sum of the squares of the other two sides. That's for a right angle triangle. For any other triangle, any side square, any side, the hypotenuse, so any side square is equal to the sum of the squares of the other two sides, and there is another additional term, minus, I'll write that in a different color, minus 2 times you multiply A and B, these two, AB, and cos of C angle. That means C angle means, so this is A, this is B, this is C, ne? This angle. If you are finding side C, angle C should come here. So there is this additional term, minus of that term. But the beginning part looks like the Pythagoras theorem. So, I mean, you can write it for any side. Say I want to write it for side A, then A squared would be B squared plus C squared, okay, minus 2, 2 මොකද?
BC
2BC
A.
2BC cos A. Or now you can write for B squared. B squared would be equal to A squared plus C squared minus 2AC cos B. The first part of it looks like the Pythagoras theorem. And in fact, it is the cosine rule. If you apply it here, see what that last term is. Wait. What is the last term here? Minus 2. It should be minus 2AB cos what?
C.
Cos C ne? Cos C ne? So C ko heti. So what is C? 90.
So 9.
0.
That's what happens in Pythagoras theorem. Okay, so even for a right angle triangle, you can write for the other sides as well. What happens is when you write for the hypotenuse, so it is the cosine rule. When you write it for the hypotenuse, 2AB cos 90, because it's 90, cos 90, that part becomes 0. So this is the cosine rule is actually a general rule that can be applied to any triangle. Okay, so I hope that is clear. So the thing is, again, when you want to find a side, you write it in this form. If you want to find I have given it here. If you want to find a side, then you make the side, like when you write it with the side subject එක side එකක් දාලා ලියන්න පුළුවන්. If you want to find A, you start with A squared කියලා. If you want to find, you can also use cosine rule to find an angle, unknown angle. Then the same formula, you make the cos A උක්ත කරනවා. You make cos A the subject, right? It's the same angle, and then it would look like B squared plus C squared minus A squared over 2BC. It's the same rule, 2 different forms. When you want to find an angle, it's easier. But it's easier. If what you want to find is an angle, it's easier to start writing it this way. Cos A it's already been subjected. This angle term, so it's easy for you to work. Okay, so when do you apply cosine rule? Now if you want to find a side here, right? What do you need to know? You need to know two sides against two sides, BC sides and one angle. But the combination is different. Here, for example, if you know B and C, the sides B and C, the angle must be this angle contained between B and C. මෙතනදී දැනගන්න ඕනේ angle එක ඒ sides දෙක අතරේ තියෙන angle එක. For you to apply cosine rule, you can do it when you know two sides and the angle in between to find the other side. Or if you know now, if you want to find the angle, what do you need to know? You need to know all three sides. If you know all three sides, make it in all three sides. If you know all three sides of an angle of a triangle, you can find any of the angles in the triangle. How wonderful is that? පැති තුනම දන්නවා නම් ත්‍රිකෝණයක ඕනම not a right angle ඕනම ත්‍රිකෝණයක you can find the three angles using the cosine rule. Shall we look at an example? It's 11:10. I will try to finish this and hand it over to custody madam. Okay. Let's do. So I have written here which rule that you have to apply. But if you didn't know, a couple of then. Okay. Can you try the first one? Two angles and one side are given. You have to find this side, X. How do you know it's sine rule? But now I have given here sine rule. If you didn't know that, how do you decide that you have to use sine rule? How do you do that? Because for sine rule, you have to know in pairs. Yugala vidiyatane sine rule එක යන්නේ. So you have to know in pairs. Let me show you. Here you have you have an angle and the opposite side. You want angle, you have the angle and you want the opposite side. So you have to see it that way. Angle side, pairs, that's sine. What's the answer? Okay, Vidusha says, okay. 6.77. Okay, got it, Ned. Let's do a sine, cosine one. Can you do 3a? Now see how that is different. Now if I didn't tell you it is cosine, you can't apply sine rule. Like a sine rule, but what do we have? We have you see, we have two sides and the angle in between contained. And we want to find the opposite side. So you can start. How do you start? X squared equals. You start x squared equals 12 squared plus 7 squared minus 2 times 7 times 12 times cos 51. Vidusha says 87.28 degrees. Vidusha අපි හොයන්නේ length එකක් නේ. වැරද්ද වරෙන්ද වෙන එකක් තුවා හොයන්නේ. Here the answer was, let me write the answer, okay? Here this x was 6.76. මෙතනත් x එකට ඔච්චර okay. So Hela says 9.3. Okay, let me send a message to Miss Kasuni. right? Is 9.3 correct? Is 9.3 correct? Is 9.3 correct? Somebody has to verify. Hello, Kasim. Bye. Okay, so yeah, so we have so many confirmations. Yeah, it's correct. It's correct. Shall we do an angle? Yeah, so this is right. This is right. Again, now I have given you here that it is sine rule. If you didn't know that, would you be able to identify which one to use? So here you have, what do we have? We have two sides and one angle. You want to find this angle. And do you see that they go in pairs? Do you see they go in pairs? If you see that pair thing going on, it's sine. So what do I mean by pairs? Angle and opposite side. Angle side pair, and here have to find this angle, and we can pair it with that side. Okay, so angle side pairs, if you can identify, it's going to be the sine rule. What is that y? What is that angle y angle? So you can start with, when you set up the equation, when you set up the sine rule, you start with y. Okay, sine y angle over 5 equals sine 53 over 7, because you can easily cross multiply and find it. Okay, so Suhela is saying that it is 34.8. Somebody can confirm. Somebody can confirm that. I know that some of you are very fast, but not everyone everyone might not be able to do it like that. So it's only one person who has given me that answer that quickly. So Akram has a different answer, 37. So looks like, okay, so it is 37.8. So this is wrong. 37.8 degrees to the nearest 1 decimal place. Okay. Suhela, check. Maybe did you make a mistake when you've been typing? I don't know. Okay, can you do the last one? See what we have there? We have all three sides, and we have to find an angle. Oh, Anushka says 34.78. Wait. We need to check that then. We are getting two different answers. Then what's going on? So you have to debate and prove your answer is right. 34.78. My calculator is not here. Okay, let me see. Let me try with my phone calculator. Okay, so it is 5 times sine 50. Okay, 37, 34. Let's see. So 5 times sine 53. Check whether you are in the divided by 7 and sine inverse of my, how do I get my answer there? 34. So you're saying it's 34. I can't get my last answer with my phone calculator. So I would have to do it like this. Sine inverse 5 times sine 53 divided by 7. It is 34.7. Now, 37 please check why you got that. It is correct. It is 34 point. Now Tivanka කියනවා first එකක් වැරදිද 10.19 කියලා උත්තරේ. See, now I didn't check, but you verified it to be 6.7. So let me first correct this. It's 30. It's 34.8, and this is. Oh, you don't rush. Okay, so it's 10.18. It's 10.1. This is 10.18. Okay, shall we quickly do the last one and finish this off? And I do have one more. Let me just quickly show you this. And I think there is another one. No, yeah, I have this here. I have not given you which rule to use. Here I helped you with that clue. In the last slide, I have a similar 4 questions to find a side and an angle by using both sine and cosine rules, but without giving you the clue. Can you just do this last one, 4A? So there you have all 3 sides and the angle. So that has to be, you can't use sine rule. Yeah, it is the cosine rule. And you start with, now you want to find x-ness, so you start with cos x. Not x, yeah, cos x equals what do you get? Now don't rush, double check and then type the answer. Without double checking, don't put it in the chat box. So Hela is giving me 111. This is 111.32 degrees. Let's see, okay? We'll wait for a verification. Okay, Shanha has verified it is 111.32. Okay. Yeah, good. Okay, so what I will do is I will leave this last slide, slide 79, for you to try on your own. If you have any doubts in this, you can always get them cleared out in your tutorial with Miss Kalpana. And that would be the end of, I'm going to leave the PowerPoint, end of trigonometry. You have 2 more topics, as I told you before, in mathematics 1, complex numbers and matrices, if I remember right. And Kasuni madam is here to continue with your complex numbers. Kasuni, hello.
Hello, thank you, madam.
Yeah. So what I will do is I will stop the record.